Today we are going to be looking at lesson 11.6, which is understanding volume. And this is going to really build on our lesson that we did last week on 11.5, where we were also working on finding the volume of rectangular prisms. Our essential question here is, how can you use unit cubes to find the volume of a rectangular prism? So last week what we did is we really just spent a lot of time looking at pictures of rectangular prisms. We were counting up the unit cubes that made up that shape, right? So if we take a look at this one, right, we see that we have 1, 2, 3, 4 cubes here in the front, and we have 1, 2, 3, 4 cubes here in the back. And if we count all of those up, we see that we get 8 unit cubes to make up this rectangular prism. Volume is this measurement of the amount of space that a solid figure is going to occupy. And we measure volume in cubic units. These units can be inches or centimeters or feet, but we always are trying to think of them in 3 dimensions, because if something is going to occupy space, right, then it has to take up volume. It has to have all 3 of those dimensions. Let's take a look at this first one here. Here we see that each of our cubes is 1 cubic centimeter. And there are a lot of them. It would take a whole lot of time to count up all of these unit cubes. So what we need to do is we need to identify our formula for finding volume. And volume is length times width times height. Hopefully what we can see from this is the fact that length times width is the same formula that we used back when we were talking about two-dimensional shapes to find area, right? So remember, if we were trying to find the area of a square or a rectangle, we'd multiply its length times its width. So we can think of volume as the area of one of our bases times the height of our rectangular prism. So if we take a look at this one, the base of this is 4 centimeters across and 4 centimeters from here to here, right? So if we were to look at this as just a two-dimensional shape, which we can kind of do by just focusing on like this part right up here, right? We would see that there are 16 squares here, right? 4 times 4 is 16. So that means that if this prism was not 3 centimeters tall, but was only, say, 1 centimeter tall, then it would take 16 unit cubes to fill that up. And we're going to take a look at this to kind of see that idea, right? So if we were to fill this in with our unit cubes, this is exactly the same as the one that we were just looking at. It's 4 by 4, and then it'll be 3 tall, right? But if we were to look at this, we were to start filling in all of these cubes, right? There's 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, and 16. So every single layer of this rectangular prism is going to take 16 cubes to fill it up. Well, we see here that it's not just one layer tall, right? Remember, this rectangular prism that we are looking at is a 4 by 4 on the bottom, and then it's 3 units tall, right? So if we go ahead and every time we add a layer, right? So for layer 1 here, this is 16 units. We'll add a second layer, which is going to be 16 more units, and then we're going to fill it in by adding that third layer, which is again another 16 units, right? So 4 times 4 is 16. And then here we have 16, 16, and 16, or we could just say 16 times 3. So what is that? 16 times 3, that is 18. So that is 48 cubic units to fill up this block. And this is a pretty fun website, right? Because we can take it and we can fold it all up so that it shows that it fits in there nice and neat in its package. So back to this idea here, right? We multiplied the length times the width. We found that the area of our base was 4 times 4, and that equaled 16, and then we just multiplied the area of our base times the height, and 16 times 3 is, as we just said, 48. Now on the other one we didn't have a label for what units we were using, but here we know that we are using centimeters. So this is 48 cubic centimeters, and we can either write it like that, or we can get rid of the CU and we can add the 3 up here as an exponent, letting us know that it's a centimeter by centimeter by centimeter, or a cubic centimeter. So let's look at another one. All right, so this rectangular prism is here, right? Here we know that we aren't working with centimeters anymore. Now we are working with inches. If we look at the base of this structure, right, it's a 3 by 2. Now, we could start with that and we could say that 3 times 2 equals 6, right? And that would be the area of the base of this structure if it was a two-dimensional shape, right? And we could call that the base. We can also, though, if we wanted to, right, we don't have to always just think about it in terms of this being the base, right? We could take this, right, and we could say, well, I want to figure out the area of the front of it here, and then work from there. And we can do that because here we see that this is 3 across and 4 high, right? So if we counted up all these little squares on the front here, we would get 3 times 4, which equals 12, right? But then we'd have to add in that third dimension, right? And we would have to think about from front to back. And we see here that it's 2 units deep. So we would just multiply our 12 times 2, and that would mean that this rectangular prism is 24 cubic inches, right? So that's if we did it using the front here, right, as our base. But we know from like everything that we've done with multiplication, right, that we don't have to work that way. We could, in fact, work with the base down here on the bottom. And in that case, we would have 3 times 2, which is 6. And then we would just multiply that by how tall it is. And it's 4 units tall. And 6 times 4 is again 24 cubic inches, right? And so these are going to be the same. Because just like with everything else, we can use the commutative property. We can change the order around that we decide to multiply our numbers in. The key to remember, again, though, is that the formula for finding volume is length times width times height. And ideally, we're going to think of this as area of our base times our height. It really just kind of makes some things easier, especially when we start to get into like composed figures and that kind of thing. All right, let's take a look at this one together. Why don't you pause the video, see if you can answer it, and then come back and see how you did. All right, here we are. So this one is cubic feet. Here we have 6 units across by 2 units deep, right? So I'm going to look at my length times my width is 6 times 2, which is 12. And then I know that my height is to multiply that by 3. So 3 times 12 is 36. And then this one again is in feet. So that is cubic feet. All right. So the next thing we're going to talk about for this lesson is talking about something that we kind of mentioned a little bit last time, and that is the difference between, say, a cubic centimeter and a cubic inch. So if you remember, last time we used like Google SketchUp and we showed the comparison there. Here we see a pretty similar comparison. Now we all hopefully recognize that 1 inch is greater than 1 centimeter. It takes almost 2.5 centimeters to equal 1 inch. The key thing to keep in mind for this, though, is that just because an inch, right, is about 2.5 times a centimeter, a cubic inch is not only 2.5 times a cubic centimeter. Because if we were to draw this in here, right, we would have to put, that's not like a perfect, right, but we would have to put 2.5 centimeters across this way. We would also need another 2.5 centimeters going down this way. Then, of course, this is a 0.5 centimeter and a 0.5 centimeter and a 1/4 of a centimeter. Right, so we can see that we're going to use a lot more cubic centimeters to fill something that is the same size as a cubic inch. And if you don't really remember that, then you can take a look back at our lesson 11.5 video, and I'll try to add a link to it here so that you can watch that part again if you don't remember it. So key here though, centimeters are smaller than inches, so cubic centimeters are smaller than cubic inches, and cubic inches are greater than cubic centimeters. So let's take a look at that and let us apply that to a problem. Here we have two rectangular prisms. And at first glance, we'll see that this one is a 4 by 4 by 2. This one is also a 4 by 4 by 2. If we look closer though, we see that the one on the left is centimeters and the one on the right is inches. So before doing any math at all, right, if they have the exact same, like numerical dimensions, right, 4 across and 4 units across, 4 inches back, 4 units back, 2 units tall, 2 units tall, right? We don't really have to do the math to figure out that the one that is made up of inches is going to be larger, right? Because cubic inches are going to be bigger than cubic centimeters. So 4 times 4, right? Length times width is 16. We're going to multiply that by its height of 2, and 16 times 2 is 32, right? So they both are 32 cubic units. The one on the left, the units are centimeters. The one on the right, the units are inches. And so because inches are greater than centimeters, the one on the right is in fact larger. Okay, we're going to take a look at a more difficult problem and add it to this lesson as well. Here we have a story problem about Patty, and it says Patty built a rectangular prism with cubes. The base of her prism is 12 cubic centimeters. It says if the prism was built with 108 centimeter cubes, how many layers does her prism have, right? What is the height of her prism? So first of all, we know that we are working in centimeters. We know that our total volume is 108 cubic centimeters. We know that the area of our base, right, so we'll call this our base area, is 12 centimeters, right? So what that means then is that whatever this is down here at the bottom is going to equal 12. So it could be a 2 by 6, and that would be 12. It could be a 3 by 4, and that would be 12, right? So what we need to figure out is how tall is this prism that she built. Well, when we talked about the volume equals length times width times height, right? And we said that this was the same as area. So that means that 12 times something is going to equal 108. So all we have to do to figure this out is we just have to divide 108 by 12. So 108 divided by 12, and it doesn't go in 10 times. So I think that it goes in 9, right? 9 times 2 is 18. Carry the 1. 9 plus 1 is 10. So if we take a look at this problem, that means then that the height of Patty's rectangular prism is 9. Remember, we were working in centimeters, so it is 9 centimeters tall. Hopefully this helps you out with the lesson for this week. Give it a try. If you have any questions, then let me know.